Okay, our next piece with increasing, decreasing functions, we need to talk about where does the function change from one to the other. What might that look like? So let's look at a few pictures here. So here's a function that's increasing, then it's decreasing, then increasing for a while, then decreasing. Let's look at where it changes. In this region of the function, the curve is increasing. See how all these tangent lines are positive, everything is increasing. But at this point, now we know what that is, that's a relative maximum. At that relative maximum, the function has horizontal tangent line, is neither increasing nor decreasing. At that point, do we see it changes from increasing to decreasing. And it continues to decrease until it hits that point. Well, what is that point? That is also a relative extremum. In this case, it's a relative minimum. And then it changes to becoming increasing again until it hits the next relative extremum. And then in this particular case, it continues decreasing from there on out. Now, remember, this arrow is to indicate it continues following this pattern. How do we know it doesn't change out here? Well, if it did, there would need to be another relative minimum or relative maximum. There would need to be a relative extremum in order for it to change from one to the other. So, a function might change from increasing to decreasing at a relative extremum. The bit of a frustrating thing is this. It doesn't always happen that way. Most of us know from your days in college algebra the graph of the cube function. You know the graph of the cube function. And you know what happens if you shift this curve to the right and vertically up and down. So let's consider this function g of x. Let's do this in a different color. Let's call this the green function. So g of x, suppose we take x and subtract 2, raise it to the third power, and let's add 3 to make this picture look a little more useful here. So let's suppose this is 2 and this is 3. Let's get rid of this piece. So this illustrates, I think, what's happening here pretty well. Here's 2, 3. So this is the basic shaped cube function, shifted 2 units to the right and up 3. So here's the graph of this function. Now, at this point, at the point 2, 3, the tangent line is horizontal. So the tangent line is horizontal, but notice what's happening with the function. Here it is increasing. It hits one single point where the tangent is horizontal, but then it continues to increase. And so what we might call this, some people would call this, some people actually use this terminology, it's a plateau. So this function plateaus, but then continues to climb. The technical word for this is a saddle point. That language comes from the three-dimensional geometry that you'll do when you get to Calculus 3. For us, I will call this a saddle point. Again, it's the same thing as a plateau. A similar thing might occur if you have a decreasing function and then it plateaus and then it continues to decrease. Just because there is a horizontal tangent line does not guarantee that it changes from increasing to decreasing or vice versa. The mere presence of a horizontal tangent does not necessarily mean it changes. It might change, but here we see it might not. Another point where it might change is something like this. Here, this function is increasing. This function is, here it's decreasing. But at that point, C, is it clear that's a cusp? And we remember what happens at a cusp. A cusp is where the derivative fails to exist. So, one possibility for a curve might, but not necessarily, it might change from increasing to decreasing where the tangent line is horizontal. That is to say, where the derivative is equal to 0. Or it might, but notice, it doesn't necessarily. Here it's increasing, and now it continues to increase. But it might change from increasing to decreasing, or vice versa. It might change at a cusp. That's where the derivative fails to exist. Well, we know what those are. Those are our two types of critical values. This is a type 1 critical value. This is a type 2 critical value. So, the points where a function might change from increasing to decreasing are the critical values. To determine where a function is going to increase and decrease, step 1, we need to find all the critical values. That determines the only values where the function might change from increasing to decreasing.